Okay, class, welcome to today's lesson, which is multiplying and dividing polynomials by constants. So to start, we're just going to review multiplying with tiles, and we're going to do 3 times 4. So with multiplications, when you first learned that, we talked about this being 3 groups of 4. And so what we can do is actually show that using our 1 tiles. So when we're using our 1 tiles, we are going to, let's go here. We're going to do a little multiplication grid. Okay, no, I don't like that one. I like it better when it's in the other direction. There we go. Okay, so again, it can kind of be done in any directions. If you're looking at this stuff online, you can see it done in different orientations. So you can have your L shape like that. I've even seen the L shape like that. But what you're doing is you're going to put 3 on one corner. So there's 1, 2, 3. So that's 3 1 tiles. And then you're going to have 1, 2, 3, 4. And so there's 4. So 3 times 4, those are what we call our factors. So now we're going to more mathematical terms. And what does that equal? Well, you all know that that equals 12. That is our product, the answer to the multiplication. So we're going to use this knowledge to do our diagram. So for our diagram, we have 3 groups of 4. So here is one group of 4. 1, 2, 3, 4. Here is the next group of 4. And you can see I'm kind of cheating now. I'm just kind of tracing the lines. And here's our last and third group of 4. And so now you can see I drew 3 groups of 4. And how many squares are there? 12. So there are 12 squares when you multiply 3 times 4. That's the area that's created using the dimensions 3 and 4. So you can look at several different ways. When we're multiplying with our tiles now, we're going to have 3 groups. This is saying 3 groups. Okay, early in the morning, having trouble writing. Let me just make it larger, easier on me. 3 groups of x plus 2. So that's what we're going to get when we multiply. So, looking here, that's not what I'm looking for. We'll just go this method. Here we go. We're going to make our multiplication grid. I don't really like it like that. How do I do this again? There we go. And I'll just move it up. Okay, so we have to get 3 groups of x plus 2. So I like to arrange the x3 here. Okay, you don't have to. It could go up there. It could go either direction. It doesn't matter. However, I like to be on the side because then it kind of matches with what we're doing. Here we have the x plus 2, so there's an x, and there's plus 1 and plus 2. So here's my x, there's my 3, there's my x plus 2. And so here's one group. Again, watch how I'm drawing this. It's like I'm tracing the lines. And there's my x plus 2. Here's my other group of x plus 2, and there's my last group of x plus 2. So looking at my multiplication statement then, I have my factors, which is 3 times x plus 2. Okay, so this is again your factors. And that equals the product. And what is my product? What is created when I multiply 3 times x plus 2? Well, there's 3 x's, and then there's plus 6. So this is your product, 3x plus 6. Notice that there are 3 groups of x, and then there's also 3 groups of plus 2. And this is what we call the distribution rules. The 3 is multiplied by both parts. There's 3 parts of the x and 3 parts of the plus 2. Parts or groups. Okay? So that's how we multiply by a constant. Let's try some more examples. Now we have 2 times 2x minus 1. So again, we're going to just create our multiplication grid. Okay. There we go. Move that here. Whoops. Having troubles. There we go. So now we want 2 groups. So we put the 1 factor on one side, and then the 2x minus 1. What are we going to have to do for the minus 1? We're going to have to shade it. So now I kind of know what shape I'm going to create. I know that I'm going to make this rectangle here that is as high, okay, or has the width of 2 and the length of 2x minus 1. And so then I'm just tracing my lines and splitting into 2 groups. Now I got to check my shading because these 2 need to be shaded. And so what's my multiplication statement? Well, my factors are 2 times 2x minus 1 equals, what have I got? Well, my product is there's 4x's minus 2. So there are 2 groups of 2x, and there are 2 groups of minus 1. And again, that's kind of an important thing that you want to see. It's really going to help us for tomorrow and for division later on. Okay, so a couple other examples here. Here we have 2 times x plus 3. So before you go and do this, before you keep watching the rest of the video, and I'll just complete it right here. There we go. Now I found it. Now I'm on a roll. All right. Here's my x plus 3. 1, 2, 3. Here's my 2. Now, the shortcut, or the long way is you draw each piece. So you draw an x, you draw an x, and draw 1, 2, 3, 1, 2, 3. Welcome to do that. A bit of a shorter cut is to draw your groups. So there's one group of x plus 3, and there is my other group of x plus 3. The super shortcut, though, is to see that you're creating this area, this rectangle, using these dimensions. So you can create your rectangle to start, and then you can trace the lines any direction you want. Okay. Now, don't worry about your diagram. If you got the pieces and it's a little wonky, that's okay. I'm fine with that. And so now you can do your multiplication statement. My multiplication statement is 2 times x plus 3 equals 2x plus 6. Okay. What if I want to do it the other direction, though? What if I wanted to do this? I want to create bracket x plus 3 times 2, right? Well, that's just going to be the same. Okay, your choice on how you want to multiply it, it all works out exactly the same. You're going to get the same product. All right. So for this one, if you want to, you can just draw it the exact same. It doesn't matter where you move it. Remember, right? These can be switched, no big deal. But if you really want to, you can draw your x plus 3. Now again, it has to be flat. Okay, so flat against this multiplication side. And there's my 2 tiles. And so now I'm just going to have a different orientation. So instead of 2 times x plus 3, x plus 3 times 2, but all my lines are going to be there. It's the exact same thing. Okay, so it is exactly the same thing. All right, so if you're going to draw it this way, you should notice that it is exactly the same. You get the same answer. Same drawing, it's just orientated differently. So let's do this example now. Now it's going to be a bit more complicated. We got 3 times 2x minus 2. So I'm going to draw my 3 here. 1, 2, 3. Here's my x plus my 2x. 1, 2, minus 2. And so now I can trace the outside of this rectangle to keep it simple. So it's like, again, the area models are like length times width, and those are your factors, length times width. And your product then is the area of the rectangle created if you have that length and that width. So multiplication statement, 3 times 2x minus 2 equals 6x minus 6. There we go. So now you can see we're starting to hit the high number of parts. So to do this without, you have to remember how this works. This again is 3 groups of 2x and 3 groups of negative 2. If you keep that in mind, that's a proper distribution. Really what we're doing then is multiplying those 2 parts. 3 times 2x and 3 times negative 2. And we use our arrows to help us with our multiplication. So without our tiles, we have 9 groups of 3x. And so that is going to be 9 times 3x. So 9 groups of 9 times. And so that's going to give us 27x. And then we also have 9 groups of plus 5. So that would be 9 times plus 5. And so that would then be 45. So that is our complete answer. 27x plus 45. Question 2. 7 groups of 5x would be 35x. 7 groups of negative 6 would be negative 42. Use the arrows to help you track multiplication because they're going to get more and more complicated. It helps you understand what you've multiplied so you don't multiply twice and make errors for harder questions. Question 3, try it on your own, then check out the answer. So 4 times 2x, 4 times plus 3. There we go. Now, what if you had it the other way around? What if you had 2x plus 3 times 4? Is that going to change anything? Well, if you want, you could just go ahead and move it to the front. That would be fine. Or you can just go multiply it. 4 times 2x is 8x. Then 4 times plus 3 would be plus 12. Okay, so if it's at the back or the front, you still are going to get the same answer. All right, it doesn't matter where you write it. It's a slightly different multiplication, absolutely, but you can definitely find the answer easily. Okay, if you want, you could write it just like this and go ahead and write the 4 up front. If it really bothers you, you're welcome to do that. Okay, so some harder questions now. This is kind of like your full meal deal. So question number 4 now, we have 2 parts to it. The first part is you multiply in the negative 2. So go ahead, you multiply in the negative 2. Making sure you use the negative sign when you multiply. negative 8x minus 6. Now, this question is separated into two parts. Because of the plus sign, we have two parts. The first part, you multiply the negative 2 inside the brackets, which it's right beside. Now, I'm going to multiply this positive 3 into the brackets that it is right beside. So the 3 times 2x becomes plus 6x. 3 times negative 5 is negative 15. Now that I've done that, I can now collect like terms. So not simplified yet because terms can be combined together. So I have negative 8x and plus 6 gives me negative 2x. And then I also have the the minus 6 and the negative 15. And that gives me negative 21. So I have negative 2x minus 21. Okay, now number 5, you try it first, then watch the video. So number 5, multiplying the 4 inside. Now the 4 is right beside those two brackets. So I'm going to multiply to get 20x. Then the 4 times negative 3 gives me negative 12. Again, the question, because of the subtraction sign, is separated into two parts. So in the next part, the second half, I'm going to multiply by a negative 2, making sure it's a negative 2. Very important. So then I multiply in. Okay, let's do this one in blue. So I multiply to get negative 6x. I multiply by negative 2 to get negative 8. Now I'll collect like terms. 20 minus 6 will be 4x, and negative 12 minus 8 will be negative 20. So there is a simplified final answer, 4x minus 20. Okay. Next part then, I'm going to do dividing. So dividing with tiles, it's a little bit tricky, a little bit different. Okay. So remember, with multiplication, you had two groups of. Now what we're going to do is we're going to have 2x plus 6 divided into two groups. So what that means is that we have a 2x divided into two groups. And we also have the plus 6 divided into two groups. So each part is divided into two groups. And that's kind of what's going to help you remember how to do division properly. Okay, so when we're drawing this, it gets a little bit weird, a little bit difficult. But here we go. So what I like to do is I like to put down my divisor first. So this here is my divisor. Okay. Then here's going to be my 2x. How do I divide 2x into two groups? Simple. There we go. How to divide 6 into two groups? Well, it's going to be two groups of 3. So there's 1, 2, 3, 1, 2, 3. So there's two groups of 3, which gives me 6. So this part in here, that's called my dividend. It's the part that's getting divided. And then up top, we have our answer, which is x plus 3. And this part here is the quotient, which is the answer to a division question. Okay, so again, each part is divided into two groups. The 2x is divided and the plus 6 is divided. Okay, let's try this next one real quick. So again, start by doing your drawing of your division. Now, if you want to fake it, it's easy to fake it. You can just fake it by drawing almost like a multiplication. I forgot here to do the division statement. Let's go back. So our division statement is 2x plus 6 divided by 2. Now I know there's kind of a line here, it's kind of odd, equals x plus 3. Okay, so you can write it like that, or if you want to use that line as a division line, you're welcome to do that. Going back here, I have 5, 1, 2, 3, 4, 5. So 10x divided into 5 groups would be 2x each group. So there's 1, 2, 3, 4, and 5. Altogether, that's 10 x's. Then I have plus 5, so that would be simply groups of 1. And there's my plus 5. So each part is divided, and I get 2x. The length of the top is 2x plus 1. So now my complete division statement is, now here I'll show you using the line, 10x plus 5 divided by 5 equals 2x plus 1. So all parts are being divided. We have the 10x divided by 5, and we have the plus 5 being divided by 5. So both parts are divided into groups of 5. Okay. So here, that's what you got to keep in mind without tiles. Without tiles, this equals 12x squared divided by 3 minus 15x divided by 3. And so you're going to divide your coefficients. So 12 divided by 3 is 4. X squared doesn't change. Negative 15 divided by 3 is negative 5, and the x doesn't change. So you get 4x squared minus 5x. Question number 2, divide each group by 5, so you get 25x cubed. Divided by 5, you get 10x squared divided by 5. And you're really watching your signs here. And you got plus 5 divided by 5. This becomes 5x cubed. The x cubed doesn't change because there's nothing to divide it. The x squared doesn't change. Now 5 divided by 5 does not equal nothing. This is a trick question. You've got to be careful and pay attention. 5 divided by 5 equals 1. So you'll notice that you'll have 3 terms here. So then in your answer, you're also going to have 3 terms. Dividing completely divides into 1. It doesn't divide into nothingness. Things don't disappear. Okay, so that's a bit of a trick question at the very end there where you have 5 divided by 5. Next question, now if you want to save time, what you can do is you can do your division like this. So 6x squared divided by 3 is 2x squared. Negative 12 divided by x is negative 4x. Really watch your sign. Okay, so you got to watch out for your signs. And then your last division is plus 6. So I got 3 separate divisions. I have 6x squared divided by 3, negative 12x divided by 3, positive 18 divided by 3. Now, question number 4, what could you divide all 3 numbers by? What would you choose as a divisor? Well, we have 56, 28, and 7. So you choose 7. 7 will work for all 3 of them. So 7 is what we would call our GCF. It'd be the greatest common factor. So in grade 10, you decide what to divide by. Grade 9, we usually tell you, but this is just leading in. So what does that give you? The first division, it gives you 8x squared. The second division, negative 4x. The last division, plus 1. Remember, when things divide perfectly, it divides to plus 1. Okay, Couple applications then. So the area of the rectangle, remember area equals length times width. So we're going to get 2x times 3, or it could of course be 3 times 2x. It doesn't matter the order, it won't change anything. And that equals 6x. So the area equals 6x. All right. Here we have a division. So now, okay, so now here, sorry, for the multiplication statement then, my bad, I should have finished that. 3 times 2x equals 6x. So when you're finding the area, it's length times width, it's a multiplication. Here we have the area. Here we have 12x. So here I could divide it into 3 groups. 1, 2, 3. And up top, I would get then this length, 1, 2, 3, 4. So I have 12x divided by 3, that equals 4x. And so that would be the missing length, 4x would be the missing length. Let me do that in red so it looks all pretty. So there's our missing answer. That is our quotient, 4x.